Hello everyone. In this module 2, we're going to learn about sketches. How to create sketches in SolidWorks. Under this, we are going to cover the fundamental of sketching in SolidWorks. Then we'll go through the various sketching tools like line, arc, rectangle, polygon, circle, spline, fillets, and chamfer. We will also learn how to edit sketch and modify the sketch using editing and modifying tools. Now in SolidWorks, to create 3D design, the first thing is you need to learn how to sketch. Once you have a sketch, you can use the features to convert into solids, as you can see on the screen. So all these features that you use are based on whether they have sketch or not. So there are two types of features. One is sketch based features and second is placed features. In sketch features, you must have a sketch to turn into solids, while other features do not require sketch. Let's say this shape on the screen is converted into 3D by first feature called extrude. So this extrude feature requires sketch. Similarly, to create a hole, you have to draw the circle. So circle is a sketch. So using cut extrude features, we are able to create this hole. And third feature is fillet itself. So fillet does not require sketch. They require only sharp corners or sharp edges. So the sketch based feature is the first features. So here you can see you have to use sketch based feature first. So sketch based feature is the first feature to be designed for any real world component. Now here you can see the extrude, revolve, rev, hole and wrap. These are the features which require sketch. While other feature like loft, sweep, dome, boundary or deform, they may use or face or edges of given component. While fillet, draft, chamfer and cell does not require any sketch. They are called applied features. In SolidWorks, sketching is by nature parametric. It means that you can create sketches that change according to certain rules and maintain the relationship through those changes. Here, those relations are dimensions and geometric relationship. Now let me explain over here. Here one line of 50 units is drawn, second line is drawn of 40 units, and third is simply joined with the first point. So this is red is called origin. Red like arrow is called origin. Now the third length is depend on the length of this 40 and 50 and along with this 50-degree angle. The moment you change these three numbers or three relation, that is dimensions 40, 50 degree and 30, this length will be decided based on that values. Now here look at very carefully, a circle is drawn which is tangent to this line as well as this line. Now if you change this dimension from 10 to 20, circle get bigger but still maintain the tangency over here. So maintaining tangency is called geometric relationship. But by changing the dimensions, we are able to change its size. So here in SolidWorks, sketching is by nature, it is parametric. So you can create a 2D sketch on selected planes or planar faces. So over here, these are the default plane provided to create the sketches. Or you can use these faces or plan surfaces for creating the sketch. Then use those sketches to create extrude feature, revolve or other entities. So relation in 2D sketch are often created between sketch entity and other model edges. Now look at over here. I have created one block. On that I have drawn this line and this semi-arc, right? So this line is basically exactly following the edge just below it. So it's a coinciding relationship. The moment this edge will change, that line is also changing. So look at this output. So by using such relations, you can control the behavior of the sketch. Now sketches has states. Sketch can be underdefined, overdefined, and fully defined, or it can be unsolvable, zero length, and dangling. Probably we have to deal with the underdefined sketch and overdefined and fully defined. These three things are very important. Now let's try to understand through these figures. Here I have drawn one rectangle. The first line starts from the origin. I have drawn in a right direction with the 50 units. Then one line over here, one line over here, or one line over. Or you can use rectangle tool to draw this rectangle. But here I have given only one dimension, which is 50. That means width of the rectangle is defined. But again height is still not defined because I haven't given any dimensions. So that is the reason why this line is showing in blue colors. This shows that this rectangle sketch or simply geometry is underdefined. Right? What does this mean? If I click this point and drag up and down, the overall height will change because still we have not given any dimensions. So such state is called underdefined, and it is always written on the bottom of the SolidWorks. Or you can simply check it that if there is an entity having blue color, it means it is underdefined. So it is not completely defined. You can drag the portion of and to change its size and position and orientation. So avoid this state of sketch. Now you must have your SolidWorks sketch fully defined. Now we are adding the remaining dimension, let's say 25 in second figure. Now this line turned into black color. Now what does it mean fully defined sketch? Now the geometry, which is rectangle over here, is completely controlled by these dimensions. If I change this 40, it get reduced. If it is 80, it get increased. Similarly for 25, right? Also this green flag is indicating the relationship. So these two lines are horizontal, these two lines are vertical. So they will maintain rectangle shape. So this is called fully defined, and fully defined sketch is having all geometry in black color. So sketch entity is fully defined by combination of sketch, relations, and dimensions. A sketch cannot be fully defined without being connected to some way to some external sketch. Over here we are using this origin to begin the sketch. If you draw the rectangle in a space without fixing this point to origin, let's say this is origin. Again, this is, let's say 50, this is 20. The size is fixed, but its position is not fixed. So we have to tie this to the external, which is in our case it is origin. You must begin any sketch in SolidWorks with this, using this origin to turn the sketch into fully defined state. Now another situation may happen that you over define it. So over define sketch is not solvable. SolidWorks cannot use such sketch to turn those sketch into 3D. So when sketch entity has two or more relations and one of them cannot be satisfied, and that unsatisfied relation will be red. Over here, look at very carefully. Here, this line is horizontal, seen from here. This is vertical, having this particular dimensions. This is also horizontal. But in this line, what I have done is deliberately, earlier it was vertical, but now I am also giving command to the SolidWorks that makes this line horizontal. Now any line which is defined vertical earlier, how can it be horizontal? So such sketch is over defined. So any geometric entity having only one state, either they can be vertical or inclined or having some at angle. But when I over define the sketch, it turns like this. It shows that red color indicate it is unsolvable geometric relations. Though vertical relation is satisfied, but the horizontal relation is not satisfied. Such case is called over defined or not solvable sketch. For example, if line has both horizontal vertical relation and line is actually vertical, and vertical relation will be yellow because it is conflicting with the but satisfying, and the another horizontal will be red. So this way you can understand what is meaning of over-defined sketch. You have to be careful about SolidWorks sketch state. It should be fully defined, should not be under-defined and over-defined. Sometimes the relations has lost the track of the entity to which it was connected, and because of that points or geometry will be shown in brown color. Now what are the best practices? It is widely considered best practice to fully define all sketches. As I cleared out earlier, you must have all sketches fully defined. This should be your best practice methods. So control how to sketch react with the potential changes. So any fully defined sketch will simply satisfy or match the design intent. It simply respond to the changes as per our expectations. Before you create new part file, I would like to suggest one changes. Go to options, and under the sketch, turn on these two settings. Enable on-screen numeric input on entity creations. Create the dimension only when value is entered. Okay, so click OK. Now click on new part file and click OK. Now I will choose front plane and choose sketch. Now click the line tool and move your mouse horizontally right side. Now you can see on the screen it's showing some numeric value. Now I want to create a 50 unit line, so enter 50 and press enter. This way we are able to create a line of 50 unit horizontally. Now this line of 40 unit, hit the enter, then join this line. Okay, now I want to give over here some angles, so choose smart dimensions or right click and move up. So that way you can use mouse gestures. Select these two lines and give some value, let's say 50. Now see, automatically third line get defined. Now if you look at where the right bottom corner, it says fully defined. So this sketch is complete. There is no underdefined entity. Now I am going to draw one circle of 10 diameters. Okay, now it is in blue color. That means its position is not fixed, its size is fixed. So select this, control, and then select this circle and give the tangent relationship. So this circle is now tangent to this length. Similarly, select this line, press control and select this circle and choose the tangent relationship. Now again our sketch is fully defined. Look at the right bottom corner. Okay, now I am going to change this value from 10 to 20. Now see, it is responding. It keep maintaining this tangent relationship. Okay, now what happened if I change this 40 to 50? Yes, it increases the length. So simultaneously the length of this third line also get increased. Okay, and similarly because of the position has changed, this circle is also moved toward left side. So it is responding to our changes. Now let's say I want to over define this sketch. So I am going to give the dimension this third line. Now see what happened. Moment when I click over here, it says adding this dimension will make the sketch over defined or unable to solve. Do you want to add it as driven dimension instead? Now sometimes you require to find the length of these such entities. So you can go driven. Driven means controlled by another parameters. If I add over here, and that would be a problem. Now see, it says unoverdefined sketch. Now which parameter is overdefined? How can we solve? So we have to click over here on this, double click on overdefined. So you can diagnose this, right? Diagnose, click. Now SolidWorks will ask you to one by one that you remove either these dimensions. Look at over here. If you accept it, let's say accept it. Now the entire sketch is solvable. So it is now fully defined. Now by changing this, let's say make it 60. So let's turn it again 50. Okay. So this way you have to understand the different state of the sketch: fully defined, underdefined, and overdefined. Now let's try to remove one of the dimensions. Now moment I remove the angle, now this is, you can say, look around the right side, it is underdefined, right? So see, I can move the geometry. So avoid such sketch. You must give some dimensions so that it can be converted into fully defined state. Now let's learn different sketching tools. Here you can see the sketching tools are basically line, rectangle, circle, arc, polygon, slot, spline, ellipse, fillet, and chamfer. So SolidWorks is parametric 3D solid modeling software. You can draw sketch by specifying points arbitrarily on drawing area. Once the sketch has been drawn, you need to apply dimensions. So this is what a simple basics, a sequence of creating a sketch. You must use origin first. You must tie any of the first geometry to origin. Now before that you need to select the plane or existing face of a feature to begin sketching. So during sketching you can apply relationship to achieve the design intent. You may need to use modifying tool to achieve the desired outcome of a shape of a part. So let's discuss these sketching tools in detail. So first is line. Now in SolidWorks we have three type of line: a simple line segment, center line, and midpoint. Center line is basically used for creating the mirror sketch or mirror features, etc. Midpoint is simply, if you click here and draw the line, it extends both sides equally by keeping the midpoint at the center. While the normal lines are simply, you have to click the points and it will keep continuing. Let's try to learn line sketch tool through these exercises. Now open new part file. Now as shown in figure, to create that sketch, now let's draw the sketch in front plane. So select this front plane and choose this sketch button. Now select the line tool. You can pick line from this sketch command manager or right click and move your mouse so you can have a mouse gestures. Now we do not have a line at this moment, we can add later, but for the demonstration purpose let's pick the line from here. Okay, now moment you pick the line, the cursor change into pencil shape and line figure or line tool indications at the bottom side. Now here orientation of line is as sketch. It can be horizontal. If you choose horizontal option, only you can draw the horizontal line. You cannot go to vertical positions. Similarly, for vertical options, only you can draw the vertical lines. And at angle, you can only draw inclined line. But 100% time, you are going to use as sketch situations, right? Now, what are the other options? For construction, infinite line, midpoint line, we'll see. Now let's pick this point over here and move right side. Because of those setting in system which we made earlier, these numeric input are showing you. So I want exactly this as of simply 100 unit. So I will enter 100. Okay. Now I'll move little up. Now see, inference line are coming up. So it says I am going to draw a vertical line. Look at very carefully, near to the pencil there is a vertical flag in yellow color. It says that this is going to be vertical. Now I want this line of 20 units, so enter 20. Now you can also give the dimension at later part, but that I think from my point of view it will simply add the overall time to the sketching. So instead, if you are very firm that this particular geometry like line, circle, diameter, arc, radius is known to you, you can simply enter the value and press enter, so that work get completed. Now I have to move on the left side. So again it will be of 20 unit. Okay. Now I have to move downwards. It will be of 13 unit. as given in the figure. Now I don't know the length of this horizontal part. Okay, so I will click it because I don't know it. So I will move upward. I know this is of 8 unit. Now on the left side it is of 30 unit. Okay, now on the bottom side exactly I don't know, but still I'm getting inference. That means horizontally and vertical line meeting at this point, it indirectly says that the height of this is 8. Okay, so I will click over here. Now I will move on the left side 15 units. Okay, now I'll go a little up and click, and I'll go back and I will enter 20, and I will move over here. Okay, now let's try to fix this sketch. So I will put this line in vertical position. Okay, I want to turn this sketch into fully defined sketch. So how can I do that? So what is missing part? So here let's put this line, select it and control this line and make it collinear. That means they are in one line. Look at this dotted line. Okay, second part, the height of this line and this line, let's say this line and this line is equal. Now see, there is no blue geometry. So if you look at the right side, it is fully defined sketch. Now press S key if you have earlier modified your shortcut key and use extrude command, or you can simply go to features and from there you can use extrude command. Now enter 10 millimeter and click OK. So we have one part ready. We simply utilize the line tool. Now let's try second exercise. Now click on new, select the part and click OK. Make sure it is having millimeter dimensions. This time I'm going to use front plane again, sketch. Now let's draw the line. Here it is of 100 unit. Okay. Now on the right side it is 35. Now downward it is of 8 as given in the figure. Don't worry, I will provide the PowerPoint presentation so you can look at these exercises. Horizontally it is 5. Now downward it is 55. Now there is no much length over here, so click and join this part. Now problem is I haven't given the length of this line. Moment I give, this geometry get locked and entire sketch become the fully defined. So go to Smart Dimensions and select this and enter the value 20. Okay. So this is our fully defined sketch. Look at it right side. There is no blue geometry. Okay. Now go to Features and select the Extrude and click OK. Right. Now let's delete these features. Now this time I'm going to use revolve features and I will choose this vertical line as a revolving line. So SolidWorks simply consider it that this sketch you want to revolve and it is of 36 degree. It is a full round and click OK. Now start new part file. Let's try to learn the other type of lines, which is center line and midline. Now let's open the sketch on front plane. Now select the center line first over here. Now as you can understand, center line basically divides the geometry or complete sketch in equal proportions. That's why it is referred as center line. Now let me draw shape like this. Okay. Now I want to mirror this sketch. So how can I mirror? Very simple. I can use mirror tool. Before that, let me give the dimensions and how the center line is very useful in dimensioning. Now let's pick this corner point and this center line and move away on a left side. So this is diametral dimensions. If you move to the right side, it is radius dimension. This is called diametral dimension. So sometimes you may come across such situation where you have to give the diametral dimensions. So enter 40. Similarly, over here, let's enter 60. Okay. Now let's enter height over here, 30. Okay. Let's enter these dimensions over here, 30. Okay. And final height is this, let's say 45. Okay. So this way we have created the sketch which utilize the center line. Now I want to mirror the entire part. Okay. So go to the mirror. Because we have a center line, so first thing is you have to select the entities. I want to mirror this line, this line, this line, this and this. Now right click or simply go over here and select the center line and right click. So center line will help us to create the mirror copy of a sketch geometry. It is also helpful in giving the diameter dimensions. Now let's talk about the midline. Now what basically it does, simply when you click it and move away, it draws the length of a line equal proportion, an equal length from that midpoint. So sometimes it is very important to draw a line from the midpoint. So you can use this midpoint as a reference line or reference point. So there will be a situation when we solve the exercises, there we have to use the midpoint line. Now let's learn second tool called arc. Now we have three types of arc: center point arc, tangent arc, and 3-point arc. In center point arc, first you have to place the center point, then the start point, and these two, first and start point, will define the radius, and the last point would be the end point. Now tangent means the earlier if you have drawn the line, it can begin the arc by keeping the tangencing relationship over here. So this is very specific type of arc. And third is 3-point arc. You have to place the 3 points, and first point, let's say first point, second point, and third point. So third point will help you to control the radius. So these three types of arc are very useful. You can also start the arc inside the line tool. So tangent arc can be drawn within the line tool. After you select the line tool for the first, then come back to the last point to invoke the tangent arc. We'll see in action. Tangency of arc depends on how you move the cursor from the last specified point in drawing area. Let's try to see in SolidWorks. Click the line tool, click over here and draw the line. Now if I move away, the line command continues. But if I want to start the arc over here, I have to come back to this start end point and look at the symbol which turned in. It is showing me that now we are going to start the arc, right? If I move pencil tool or cursor over here, I am going to draw such arc. If I turn that part and downside, again I am able to draw such type of arc. If I move the end point over here, this will be the arc. If I turn over here and I will click over here, this will be the arc. Again line 2 continues. Now I want to draw one more arc from which is tangent to this end. Then I have to go over here. I have to choose this tangent arc. So click this, look at this. So it will create an arc which is tangent to that line, earlier line. Now let's draw a line over here again. Okay. Now let's come back and let's draw the arc. Then line continues and I will finish the sketch. Okay. Now here it looks like a sharp edge. So let's turn this relation to the tangency. So select this arc, control, select this line and choose the relation make tangent. So using line tool, we can use the arc tool as well. Now here, if you want to create, let's say this is my center point. I want to create an arc starting from this point to this point. So this is very simple, easy to understand. Now third is 3-point arc. So click over here, first point, second point, and third point, right? So this is how you can draw the arc. Now if you choose this arc, the property manager will show you certain property of an arc. Start point, its coordinates, end point, its coordinates, and third center point, its coordinates, and its radius, right? Or simply I want to turn this arc into construction, then I can go to the turn into the construction line. Construction means center line. Now center line cannot be used to create the extrude feature, revolve feature. It has to be a continuous line. So sometimes you need to turn sketch or line or any other geometry into construction geometry. Now let's draw these two exercises to strengthen the concept of arc in SolidWorks. Now open new part file, choose front plane and sketch. So the exercise 2.3, let me draw a line of a 20 unit length. Then on upward side, it is 20. Okay. I will go and come back to initiate the arc and gradually move up to left hand and the end point. Now it says that the starting point and end point of arc are aligned. Now click over there and move downward. Now look at very carefully. The yellow flag says the line is vertical and it is also tangent to the arc. And select this part. Okay. Now place this or select this and make it vertical. Yet it is not fully defined. Why? I can pull this and change the geometry. With these changes, we can understand why it is not turned into fully defined. This arc is not tangent with this line. So select this, control, select this and choose the tangent. Now it turned into the fully defined sketch. So look at the right bottom corner. Okay. Now how can we draw similar things in a different way? So let's delete this part. I will use rectangle tool, which I have not taught so far, but still it is very easy to understand. So vertical line is 20, horizontal is, press the tab and enter. So I have a bottom part. Now let me use this center point. So this is my center point, starting point and end point. Okay. Now I turn this into construction line. Okay. So it's the same solutions, but by using the rectangle tool, which is very quick. So you may have to use your brain, which tool you need to use to get the same outcome. Now click on front plane and start the sketch. Now here, let's use center point arc. So this is my center point and starting point, and I will go come back to the downward. Okay. Now let's give the dimensions. This will be 25. Okay. Done. Now let's do the same thing for another arc. Same center. This is starting point and this is ending point. Okay. Now the radius is for the outer arc is 40. Okay. Now let's draw the lines. Let's say of 50. Okay. Go over here and close this. Now from here it is 50, then downward, use the inference lines and close the sketch. Okay. Now let's give the dimension 15 and make this line and this line equal. So this will turn the sketch into fully defined. Yet we have to equal this line. Let's say this line and this line are equal. Okay. Now by giving the relations and dimensions, we turn this 2D sketch into fully defined sketch. So go to features and select extrude. Now give the depth 40 as given in the exercise and click OK. Let's try exercise 2.5. Click new part, OK. Select the front plane and click sketch. Now let's try to customize mouse gestures. Okay. Now here I'm going to search line tool and I will drag over here. Okay. And I will use circle on a left side, rectangle bottom side and dimension up side. Okay. So click OK. Now I want to use line command. So right click and move right side. It will start the line command. So this will be of 300. Okay. Now this portion is of 60. This is of 40. Now I want to go back and create arc. Okay. So what should be the radius? Here in the exercise it is 30. Okay. Click over here. Now move left side by 80 unit. Now move little bit. Come back. If by mistake if you have started the arc, come back over here. If it is not getting, press escape and again choose the line tool. Now come back here to initiate the arc and click over here. Okay. Now let's dimension this part as 80. This is of 60. Okay. Now let me finish these portions by drawing the line. Okay. Choose this part and make it tangent. Okay. Now let's extrude 50. You can enter dimension directly on a keyboard and hit the enter. This is how you can use line tool and arc tool to create the sketch. Now let's learn third drawing tool called rectangle. Now there are 5 types. One is corner rectangle, second is center rectangle, third is 3-point corner, means all these 3 points belongs to corner. Fourth is 3-point center rectangle and lastly is parallelogram. Now along with while drawing the rectangles, you may add construction line from the corners or from the midpoints. So these construction lines are sometimes very useful to place another geometry. Now the first corner point will be this, second will define the width and third will be the length. You can also draw the rectangle having some inclinations. Now let's try to see the various types of rectangle in SolidWorks. Open the part file and choose the front plane. Now here, let's try the first part, that is corner rectangle. Select that. Now look at the property manager. So we have options. First is activated. If you want to use second, you just click over here. Another option is to add construction line. Now let's try from origin and try to move away from that point. So this is my second point. Because we have started the setting in system options to add the dimension while entering the inputs, I can define the width and height and press enter. Okay. Press escape. Now let's try another things. Click over here again rectangle tool. Now this time I'm going to click this construction line options. Okay, now here from corner it is given. So if I draw like this, so additionally I'm getting the construction line connecting to their corners. Okay, now let's try this center point rectangle. So this will be my center, and then I will move to define its width and height by placing the second corner point. Now let me select and delete. Now let's go for third options, 3-point corner rectangle. So let's put first point, second point, and third point. Okay. So this way the first 2 points will define the width and third point will define the height. Now fourth option is center rectangle, 3-point center rectangle. So let me place over here second point, and then I will move away. So based on what is given in your sketch, you have to choose out of these 5 options the rectangle tool. Okay. Now third is parallelogram. So select this point, second point, and third point, right? Like this. Okay. Now you can simply give the dimensions, angles, and turn them into fully defined sketch. So rectangle tool is very useful. Now for example, if I want to draw the square, what will you do? Will you use line tools to do that? Or simply you use the rectangle tool to do that? I suggest, or maybe you will agree, that rectangle tool is very quick. So, and simply enter the dimensions. So that will give very quick square, right? So sometimes we need to think which tool is very effective to complete the sketch. Now the fourth tool is circle. Now circle do not require any much explanations. In SolidWorks we have a simple circle where we have to place the center point and the radius point. And second option is perimeter circle. Now when you invoke the center tool, you will have 2 options. That is to have first options, and second is perimeter circle. So place the center point and move the circle away to define the radius. So this will place the circle. Second option is perimeter circle, where you simply draw the circles which are having relations of tangent with the other 3 or other line tool or maybe other drawing geometry. This option called for construction will turn the circle into construction circle. I mean to say center line type of circle. So construction circle, sometimes let's say pitch circle. You want to place the circle or small circle on this. So this your main circle will be your pitch circle. So you can draw using construction options. Now start a new part file and open the sketch on front and try to draw such geometry. Now click on circle, or you can use mouse gestures. Okay, I will use the mouse gestures. Now I want to draw a circle by placing center over here and moving towards right side. Now enter the radius, or simply add some value, let's say 30. Okay, so I have drawn the circle of 30 millimeter diameter. Now it is already selected. So if you click this for construction, this option will turn into construction circle. Now second option is perimeter circle. So I have to give 3 options: one tangent options, second tangent options, and third tangent options. I have placed the circle. A circle is already drawn. Still it is selected. So because of that, you can have an option to turn into constructions. If you simply escape it, it will draw the full line circle. So circle is very simple tool in SolidWorks. Now let's try the fifth tool, polygon. Now polygon is multi-sided geometry having all sides of equal length. an equal angle. This is the definition of polygon. Look at the hexagon shape where all 6 sides having same length and all these angles are having same value. So when you invoke the polygon tool, you have to enter the number of sides you want. If you enter 5, it turns into pentagon. If you enter 4, it will give you the square. If you enter 3, it will give you the equilateral triangle. If you enter 6, it gives you the hexagon. So there are two options over here. One is inscribed circle and second is circumscribed circle. Now in case of inscribed circle is used to draw polygon outside of the construction circle. So look at this. So this is our construction circle. So we are drawing this hexagon outside. What does it mean? Means from here, this center point of a circle, construction circle, we are providing this distance, or you can say it's a distance of a side from the center of a circle. In case, that is, if the distance between center of a circle and side of polygon is given in sketch, then you have to use these options. Second is circumscribed circle, where polygon is drawn inside of constructing circle. So this is second figure I am talking about, where the polygon is inside of circle. So what does it mean? From this origin, or you can see the center of a circle, this is the distance of end point of a polygon. If the distance between center of a circle and corner of polygon is given, use these options. Now you can give the dimension to these sides to fix this geometry. Now open new sketch on a front plane. Choose this polygon tool. Here I am going to use inscribe circle options. So I will choose origin as center point and I will move away. Look at this. And I will click over there. Moment I click it, the SolidWorks simply place this circle. Okay. Now look at over here. If you want to turn this polygon for construction, just tick this because it is already selected. If you want to create new polygon, click on over here. So the first polygon remain there. You can start the second polygon and click OK. Now how can you fix this sketch? Now see, because center is fixed at origin, but its dimension is not given, so we can change its size. So click on dimensions and click the diameter of this construction circle. Let's say it is 50. Okay. Yet it is not turned into fully defined sketch because I haven't fixed the orientation of side. Let's say this side will be horizontal. Now it is turned into a fully defined sketch. Let's say I have given in the sketch side to side dimensions. Select this diameter and delete it. Again choose this and side to side dimensions. Okay. Let's say it is 55. Now let's try another options. Polygon. Now this time I am going to draw pentagon and circumscribe. So click over here and move away a little bit, and that will place the pentagon. Now here polygon is inside the this construction circle. Now let's give the dimensions. Let's say 30, and let's make these as horizontal. Yet it is not turned into fully defined. Why? Because it is just moving around in the space. So I have to drag it, or I have to assign to any other third geometric reference point. Let me put over here. The moment I place it, it turns into fully defined sketch. Now let me try to create a square. So enter 4 over here and click and move away. So you can draw square even. So let's make this line horizontal. Okay. Let's give the size. Let's say it is 30. And drag this and put it over here to fully define. Now let's try the equilateral triangle options. So enter 3 and move away. Now I want to make it horizontal. So make it horizontal and give the dimensions. So Polygon tool is very helpful to create the polygon in Sketch. The sixth drawing tools is slot. You can draw straight slot and arc slots by using the tool in the slot 5 out. Now we have a 4 option, 1, 2, 3 and 4. The first option is straight slot. Second is straight slot but having center point for defining its width. Third is 3-point arc slot and fourth is center point arc slot. So you can understand these are simply derived from the arc options. Straight slot tool is used for drawing a straight slot by specifying its start point, end point and a point on a defined width. So start point, end point and this point, second, third and this is first. So this 3 point will help you to define the straight slot. Under the slot property manager, you can choose type of a slot and option to add dimension to the slots. So look at over here. If you tick this, so while creating slot, dimension will get added. And this first option will add dimension from center point to center point and the width. You can see from the icon. If you choose this option, overall from circumference to circumference distance get added and the another dimensions remain same. If you want to turn your slot tool into construction geometry, just tick this. So let's try these slot tools in SolidWorks. Open the sketch on front plane. Now let's try the first straight slot option. Click over there. Now here I will remain on these first options and I will go with the add dimensions option. And even that I will choose these first options. So choose over here, move away and move away. So first point, second point and third point. Now you can change this dimension. Let's say make it 60. Now let's make it 20. Okay. Now let's try another options over here in a same slot. Second options for the dimensions. Click over here and over here. Now this time dimensions get added from this point, that is circumference point to the circumference point. Now in case let's say you have used the first options of slot and even this dimension options. Now you want to change the dimensions not from center but from circumference. How can we do that? Just choose this smart dimension option, press shift, select this and this. This will give you the dimension from outer point of arc to the outer point. Let's make it 60. Now let's try another options. I will add the dimensions. I will choose this and because it is center point options, our length start from the center point and span to across equally from the selected point. That's why it is called a center point slot tool. Select it and click. Now let's try the third. That is first, second and third and move away. So moving away will define the width. If you wish, you can simply drag the center point and tie it to the origin. Now this dimension would be, let's say 10. I want to change this to 25 and this angle to 60. Okay. Yet it is not fully defined. So what can I do? Very simple. I will choose this part and control and choose this origin. Or you can simply I put it in a center line, or I can use center line draw over here and tie to this. This will also turn the slot sketch into fully defined state. Now let's tie the last option, center point arc. So click over here. This is our center point. This is our start point. And let's say this is my end point and I will move away. So this way I have a slot tool. Just give the dimensions as per your requirement and turn them into the required sketch. If you want to turn into construction, select these options. So this will simply change the geometry into construction geometry. Now let's discuss ellipse tool. Now ellipse is defined by dimension of major and minor axis. So you have to provide major and minor axis dimensions. You can also draw elliptical arc by using partial elliptical tool. So we have 4 options in under the ellipse itself: partial ellipse, parabola, and conic curve. Now you can draw the parabola by defining its focal point, apex, and 2 points. That is start point and end point on the parabolic curve. Now many times you need to draw the conic curves. So for that conic curves, you need to understand the concept of rho value. If rho value is less than 0.5, it will give you the ellipse. If it is equal to 0.5, its shape would be equal to the parabola. And if it is more than 0.5, it would be the hyperbola. So here we have to first provide the focal point, this apex point, then start point and end point. Depending on the value, this conic curve will be ellipse, parabola, or hyperbola. Now open new part file and start sketch on front plane. This time I am going to pick this ellipse tool. Now here I will place the center, then dimension of a axis and these dimensions. So it depends on which dimension you keep smaller and larger. Based on that, you will have a ellipse, vertical or horizontal. You can also draw an ellipse having some inclinations. So it's very simple tool. Now let's try partial ellipse. So click over here, then this point, and let's start the finish point. So partial ellipse basically it's an elliptical arc where its partial geometry is not drawn. Now let's try parabola. So click over here and place the apex and then your start point and then your end point. Okay, let's try one more. So click over here, apex point, starting point and ending point. Now it is selected. You can see on the left side on property manager, you can modify this value. Now if you want to turn into construction, then choose this. Now what if I want to turn this partial ellipse into construction? Select it, right click, and you will have these options, construction. Now let's try conic curve. This point, and horizontal. Okay, and fix this focal point over here. So this way you can control the conic curve shape. Now let's try one more time. Now place the apex and now the focal point. Look at the value. If it is more than 0.5 and equal to 0.5 and less than 0.5, right? If it is less than 0.5, it's going to give you the elliptical shape. If it is exactly equal to 0.5, it would be parabola. And if it is more than, it is going to give you the hyperbola shape. So this way you can draw the conic curve. Now let's discuss spline tools. Spline tool is used to create smooth curve. It is widely useful in surface modeling. You can draw a spline by specifying 2 or more points, which are referred as control points in drawing area. If you look at over here, where you try to draw the spline, it will offer you handle. Now handle has three type of handle. One is diamond, second is arrowhead, and circular. Diamond will help you to orient the part of a curve, and this arrow will change the magnitude of tangency, and this circular handle will do both at a time. There is also a spline called a style spline. Now under style spline you can have this control point. So through control point you can control the curvature of a spline. And lastly we have a fit spline. Sometimes let's say I draw block like this. Okay, so this is line and this is arc. So when you create a 3D part, it will give you the hard line over here. So instead of just leaving over here, we can convert this geometry into fit spline. So when you extrude, this hard line will get removed. So sometimes fit spline is used for getting the smoother surfaces. Now let's try spline. Open the part file and start the sketch on front plane. Now here I will use this spline tool. Now I will click first point on origin, second point over here, third point over here, and fourth point over here. And I will press the escape key to come out from the spline tool. Now you can see here, this is control point, this is control point, and this is control point. When I select this spline, it will offer me handles. Now these handles are basically used to control the curvature or overall shape of a spline. Let's pull this way. You can also give the geometric relationship to these handles, right? So let's make it vertical. Now let's increase the magnitude, and same you can just have some inclinations. Similarly you can manage over here. So spline basically give you a smooth curve for your modeling. Now instead of using this handle, if you want to use spline, I mean to say, for controlling the entire shape, just select, right click and show the control polygon. Here using this control polygon, you can do the same thing. You can control the shape of a curvature like this. Now you can also start the show curvature comb. So this will help you to control the surface, right? If you have some idea about this curvature, that is called curvature comb, I think you can, the larger these lines, that means here there is a sharp change in radius. The radius is less and hence the curvature is higher. So curvature is inversely proportional to the local radius. Here you can see it is smoothly transitions. So for in surface modeling, splines and this curvature comb are used to create a uniform surface. Now open the leaf part file. I will provide its link in description. Now this picture is inserted on front plane. Now using spline, I want to trace out this outer surface on a both side, and I want to create a 3D shape. So again select the front plane and open the sketch. Now let's go to the spline tool. So I will start from here, second point, third point, fourth, and the fifth point. Press escape. Now choose this handle and try to manage the curvature like this. If you have a difficulty, you can right click and start the control polygon. So almost you can say it is just simply following the outer geometry of a leaf, right? So using this handle you can draw curve like this. Now let's draw one more curve from here, second part, third part, fourth part, and fifth point. Okay, press escape. Now select this and again try to match with this curvature of a leaf. Now let's say right click and show control polygon. With this, you can also control the curvatures. For me, control points are works better. Okay, so try to control this point and match with the geometry. Once it is done, you can exit. Now, because leafings come in a way, let's hide it. Select the sketch 1 and hide. Now select this sketch 2. Now let's go to features and extrude and select this curve. Okay, now let's extrude, let's say by 20 millimeter and click OK. Now here on this face, I will open one more sketch and I will turn these outer edges, that is as a sketch line. So convert entities. So I have exactly a smooth curve. So this curve simply follow the edge of extrude features, right? Now let's go features and extrude that part. This time I will start the draft angle and it will be inward. Okay, you can see very carefully and I will click OK. Now let's say I want to change the underneath curve. Now here let's pull this spline little bit over here. Okay, and like this. So also over here. Now I will exit it. Now what will happen? The change has occurred as per expectation. So underneath spline is changing these first features, and because first feature has changed, is the you can say the another sketch 2 of boss extrude feature 2 is also changing accordingly. So this way we can use spline tool to create a smooth surfaces. Now open part file and start sketching on a front plane. This time we will see the fit spline. Here I am going to draw a curve like this, and then I will come back here and I will draw the shape over here. Now let me extrude and show you what happened. You can see the hard lines. This is hard line because this segment is arc. I don't want it. So what can I do? I simply come here and edit the sketch and I will select the entire part, or simply this part, control this and this. Okay, then I'll go to tools, spline tools, and I will select the fit spline. Now you can see it is try to draw a spline following the underneath geometry, and click OK and exit. Now see the hard line has gone. So this is how the fit spline is used to create the smooth surfaces. Now let's discuss fillet command. Now sketch fillet tool trims away the corner. It simply round the corner. Okay, if you have inverted, you simply add the round at the intersection of two sketch entity to create the tangent arc. This tool is available for both 2D and 3D sketches. We haven't discussed about 3D sketches. We'll see in futures. Now, for example, here we have a square of 72 by 55. Now I want to turn this corner into rounding. So I have to use the fillet tool. I have to select these two corner. Before that, I have to give the radius value, which is 5, 10, depends upon your requirement. Now here we have here keep constant corner option ticked. Now we'll see through practice what does it mean. So moment you apply OK, it turn this corner into round. So you can say we have given the fillet. Now under the fillet tool, we have sketch chamfer as well. It is similar things, but instead of giving the round corner, it gives the slant edge, incline edge. Now sketch chamfer tool applies a chamfer to adjust and sketch entity in 2D and 3D sketches. Now in chamfer tool, we have two options, angle distance and distance. Under the angle distance, when you say 45 degree, so here we'll have a 45 degree. Okay, that is from here it will move the distance, let's say 15, then it turned 45 degree and try to remove the rest of the part, okay, sketch part, and it will give you the chamfer. So you can control the chamfer by angle distance or distance. So under the distance, you can give the equal distance. Here it is equal distance, 15, or you can untick this and you can have a two separate distance, 15 and 10. So it's a very simple tool. Now it is also available in Feature Manager tree, where you can directly apply the chamfer and fillet in 3D environment. So wherever it is possible, use this fillet and chamfer tool in 3D environment instead of 2D sketch environment. Now open one more part file. Select the front plane. Now let's draw the rectangle here to understand the concept. Now give the dimensions 120. Let's say 80. Okay. Now click on Fillet tool. I want to give the radius of 10 millimeters. So I have to choose the entity. So this corner, this corner, this corner. So you can see what have sketch tool has done. It simply round this corner. It trimmed away the extra lines. Constraint corner. Let's try to understand that part. Okay. Now let me draw a shape like this, and let me give some dimensions, 30, and let's say again 30. Okay. Now I want to round this corner. So what happened? Let's say the radius is 5. Now by turning these options, keep constant corner on, what happened? Let's see. So it will maintain the dimension relations from that virtual sharp corners. That is what the meaning of that keep constraint corner. Now on the screen you have a rectangle of 80 and 120. Now let's try sketch chamfer tool. Here under this we'll try first option, angle distance. Now dimension is 10. Instead of 45 degree, I will choose 60. Okay. Now moment I select this, see from this corner it move by 10 mm, and then 60 degree it draw the line and it trim away the rest of the geometry. Now let's undo it, and now this time let's make it 45 degree. So this chamfer, this chamfer. Now let's try one more time, but with the another option, distance. Here distance is 10 millimeter. So click here, right click. Now let's try the different value rather than equal value. So here it will be 15 and this will be, let's say, 20. Okay. Now if I click over here, so this will be 15. So this way you can use the sketch tool to create the sharp corners, or you can say the inclined corners.